Hello and welcome to Science Visualized. Today we're looking at reactions of carboxylic acid derivatives. So the first one here, you're starting with an acid halide, acid bromide, and you're reacting that with dialkyl copper lithium. So that should be a CH3. And that will give us CH3 nucleophile. So the nucleophile will add to that carbonyl and eventually you end up replacing the bromine and the product will be, and now you have the nucleophile added to that position. In the second reaction, you're using an amine, which is a neutral nucleophile, therefore it's going to lose one hydrogen, and that will replace the leaving group, the chlorine, and you end up with the product. And now instead of the chlorine, we have the amine with one hydrogen because we lost one hydrogen, and then you add the other alkyl group. Next, hydrolysis or reaction with water, either under neutral conditions, under acidic conditions, or in this case, under basic conditions. All of them will introduce an OH nucleophile, which will replace the chlorine, the leaving group, at the acyl position, and therefore you end up with this product. And now instead of the chlorine, you have the OH nucleophile. Lastly, BH3 does a strong reducing agent and it gives H- nucleophile, and it will add it twice. So the first time will convert this one aldehyde, you replace the iodine with the hydrogen, but it does not stop there. So you get the first hydride added there, but it doesn't stop there. It adds again the second time, and therefore that becomes an alcohol, and now you have two hydrogens added to that position. So basically reduces it to an alcohol. Number 2, it says identify the following carboxylic acid derivatives by their general family names. So this is acid halide, or you could say acid bromide. That's an amide, and this one here is an acid anhydride. And the reason it's an acid anhydride, you have a carbonyl, oxygen, and then another carbonyl. Last one, provide the mechanism for this reaction, and we see that this leaving group at the acyl position is being replaced by the nucleophile, the alkoxy nucleophile, and you end up with the nucleophile occupying the leaving group position. So what happens in this reaction is you start with the acid halide, plus I'm going to rewrite the alkoxy group like that. So I still have the same number of carbons, 2, 3, 1, 2, 3. And then the nucleophile, it's going to be the O-, and that will attack the carbonyl carbon, and then the electrons will flow to the oxygen to make an O- or alkoxy group. O-. You still have the Cl connected, but now we've added a new group. Let me use a different color for that. We've added O with that alkyl group, and this is called tetrahedral intermediate. And then the last step now will involve the electrons on the oxygen coming back to form a double bond, and at the same time kicking out the chloride leaving group, giving you this product. Now that becomes a carbonyl, carbon double bond oxygen, and because we lost the chloride, we're only left with the alkoxy group added to that position. Thank you very much for your time. Please subscribe.